that exponent of the 3 tells us that there are going to be 4 terms. So in Pascal's triangle, 1, 1, 1. I only have to go up to here. 1, 3, 3, 1. And go 1, space it out, 3, space it out, 2, 1. Does it make sense? If you wrote it out, again, sometimes find, I don't know if I would write this out if I'm you, but I imagine this. Yeah, I would not write it out, especially if that exponent was an 8. But if you wrote it out like this, it should really make sense that your first one is going to be that 4a times 4a times 4a, which will be 4a squared 3 times cubed. Plus. Well, now we're going to have our 4a squared twice and our 2b once. Then we're going to have our 4a squared once and our 2b twice. And finally, the last one would just be that 2b times 2b times 2b, which will be 2b cubed. Which would give us 4 cubed, 64a to the 6 plus 3. Again, I'll just take my time and do it one step at a time. I'll do all of the exponents first. And then after my exponents, 48 times 2 is 96. A to the 4b, 16 plus 48, a squared, b squared. And just number 7 for practice. So now a pattern is happening, okay? A pattern is happening that the blue numbers in that first step are always related to combinations. Because you're like, oh, I chose 1 2b. Of the 3 2b's, I chose 1 of them. That's why it only has an exponent of 1. How many ways could that be done? 3 choose 1. That's how I got the blue 3 out in front. Then there's a pattern with the exponents. We start off with the 4a squared with all of them, and we go down by 1. We start off with none of the 2b's and go up by 1. So that pattern results in a formula, and what the formula does is it's a formula for each individual term. And that can be found on the bottom of page. Your textbook has a formula and your formula sheet. Let's go to the bottom of page 741. And we'll write the textbook formula as well. And they're slightly different. Okay? On your formula sheet, you have the following formula. On your formula sheet, they do not give you this part in purple. So let's do a little bit of comparison between our textbook formula and our formula sheet formula. Okay? What this is trying to tell you is you can find any term in an expansion. For example, we're going to do something like this. There's 12 terms. That's a lot. They're not going to ask you to do all 12. They're going to ask you to do all of them. Usually the exponent's like a 3 or maybe a 4, like we just did. But if it's 12 terms with an exponent of 11, instead they're going to say, could you find the 8th term? And if you're finding the 8th term, this is notation we use for term H. Okay? Well, in front is a combination. Which combination is it? Well, the n comes from the exponent. But this purple part's not on your formula sheet, so you're going to have to remember the n is the exponent. Choose k. If I wanted to find term 8, does it make sense that k would be 7? Because I'm finding term 8, the only way that k plus 1 is 8 is if k is 7. Complex mathematical proof to show that, but will be on the scope of this course. A is whatever your first thing is. So just like in our example before, you have 2x. This tells you how many times you have that 2x. 2x to the n, that exponent, minus whichever term you're at. And then your b is the second term, and it's to the exponent of k. The textbook made it a little bit more complicated because they used, instead of k, so here we're using k here, and we used k plus 1. The formula in the textbook said, let's just make it term k. But then these all had to be minus 1s, which makes the formula a little bit more cumbersome because you have more places that you have minus 1s. So I think that the formula sheet formula is actually easier to use. We're going to highlight that, copy it,